Alright, now we're ready for fun. Section 2.3, solving right triangles. As I said before, that means to find all of the sides. So there's basically two possibilities. If you're given an angle on the triangle, so for example it's a 90 degree, it's a right triangle, so one angle is 90 degrees, but then some other angle is 20 degrees or whatever that is, you'd be using sine, cosine, or tangent to find lengths. The other possibility is the angle theta is not given, so then you would end up using either sine inverse, cosine inverse, or tangent inverse to solve for the angle. For example, solve for x and y here. What a beautiful triangle, can't believe I made that myself. So to solve for x and y, we need to set up either sine, cosine, or tangent. Well, tangent is out of the question because that would be y over x. That doesn't use the number 5. So tangent is out. How about sine? So sine is opposite over hypotenuse, so that would be y over 5. Then just multiply both sides by 5. Get your handy calculator out, and you'll find out that y is equal to 1.462. Good enough? What about cosine? So that's going to use the x, ooh, fancy, x divided by 5. So again, multiply both sides by 5, and we've got our decimal answer at 4.782. So you could check the answer by doing the Pythagorean theorem. So x and y squared, x squared plus y squared, should equal the 5 squared. And try it out on your very own, and you'll find out it is true. So in this type, which our textbook likes to use, they just tell you in words what's happening with the triangle. You have to draw it yourself. So triangle ABC, where we've got C as the right angle. Angle ABC is another way to say angle B is 23 degrees. And from A to B, which is the hypotenuse, is 9. Find BC, this side. Another thing you can do with these videos is put it on pause. Get it? It sounded like it was on pause. You put it on pause, and then you could solve the problem yourself, then unpause it, and magically you see, hey, I got it right. I used cosine as well. And I got the answer 8.285. Okay, so those were two of the most basic examples. Now for something a little more fun. So much more fun, I couldn't really draw it on the computer very well. So we have my beautiful rendition here. Now this one has two triangles, and x, y, and z, and the angle theta we have to solve for. So let's see. First we're going to solve for x. So use just this little right triangle right here. Ignore the 10, the theta, and the y. Just look at this little triangle right here. And if you do cosine of 48, that would be x over 7. Again, like the last one, multiply both sides by 7. Use a calculator. We've got x. Next up is z. So again, using this little right triangle right here. So this would be opposite and hypotenuse, so we would have sine. So sine of 48 is z over 7, multiply by 7, and there is the z, 5.202. What's next? Well, next, what you do is you look at the whole big triangle. So we're done using this 7 and the 48, so I take that out and just look at the whole outside triangle. The bottom length is going to be y plus x. So here it is, y plus x. Then we could solve for theta. So use sine, that would be the opposite over hypotenuse. And then to solve for an angle, you use sine inverse. That's the whole job of the inverse trig functions. So sine inverse of this turns out to be 31.346 degrees. And then for the last part, solve for y. So we could use this side and this side. You could use the 10 if you wanted to use cosine. You'll end up with the same answer at the end. But I decided to use, this is the theta, 31.346, and tangent is going to be 5.2 divided by the y plus 4.684. Then cross multiply or multiply by y plus 4.684 to get it over here, divide by tangent, then rely on a calculator to figure out this last decimal part. And there we have it. Look at that. 4 problems in 1. Beautiful. And now for the last example. Again, one triangle inside of another triangle. This problem, though, is different. And this type of problem we're going to have when we do applications and things like that. The application would say a person was standing here, they were looking at the top of a building, and the angle of elevation is 50 degrees. Then they backed up by 20 feet, and then they noticed that the angle of elevation was 28 degrees. So then find out how tall is the building and how far away were they when they first started. So again, this would be a great place to put it on pause. And then, once you've finished it, come back here and check out how I did it. So first of all, split this into 2 triangles. There is the little triangle that has x, y, and 50 degrees. Put that over here. Then there's the whole outside triangle that has 28 degrees right here, 20 plus x on the bottom. Both of these have opposite and adjacent, so they're both going to be using tangent. So set up the tangent ratio. Notice that this one has y in the numerator and this one has y in the numerator. They're the same. So what you could do is solve for y. So just multiply by x here, multiply by parentheses 20 plus x here. And if they're both equal to y, then they have to equal each other. So you just take this one on the left, put it over here, take this one on the right, put it right there. Now what we do is, what I would do is divide by tangent of 28, put these 2 tangents together, get the old trusty calculator out, and find out that when you divide these 2, it's the decimal 2.241. So that is times x. Then what we need to do is subtract x from both sides. So that will leave 1.241x. Then divide both sides by the 1.241, and you'll get what x is equal to. Once you have this number for x, then just go over to this one and plug it in for x. So then you would have y equals our value for x times tangent of 50. So y is 10.636. All right, so that's it for the notes on section 2.3. Please go back to my website where it said there's a section 2.3 quiz, and print out the quiz, do the work, and turn it in on Wednesday. That's right, it's due on Wednesday. Bye.